Hello everyone, this is Ms. Thomas, and today we're going to look at the 7-6 reteaching worksheet that you guys had in class. Someone had a question about some of the questions on that sheet. So this screenshot was sent to me, and it's from that worksheet, and it's on the back side, and it says, for each of the tables on the previous page, extend them 2 units in each direction, use common difference in the x values and common ratio in the y values to do the extension. The first table is done for you. So all they're showing us is that first table, they really just use the fact that this is being multiplied by 3 every time, as these are increasing by 1 each time, to help extend the table out. And then it tells us to plot the points in each in each of the extended tables on a separate coordinate grid, connect all the points in a smooth curve. The domain of each function, and we want to remember domain is your x values, is all real numbers. So that means I can put any values in here and they will work in the function. But the range is all positive real numbers. So when we look at this list, we do only have positive real numbers, even as our x's get into negative numbers. And we want to explain why there are negative values for x but not for y. So we want to remember that our exponential equation, this one is probably just looking at our starting amount and looking at our initial amount, right? If we're multiplying by 3 every time, that's our r. So keeping in mind that all of our exponential equations are y equals ab to the x, well, my r is the same as my b. So it's like having 3 to the x, and then if it's going to equal 9 here, it's got to be 3 times 3 to the x. So this would be the equation, and you'll recall that when you're raising a positive value to any exponent, it's not going to change that value to a negative. So I could raise this 3 to a negative 3. And all that's going to do is make it 1 over 3 to the third using our rules of exponents, which is 1 over 27. So even though my inputs become negative, all that does, because my inputs are an exponent, is make the reciprocal of what was originally being raised to that exponent. We can look at more examples from the other tables. So these are the tables from the previous page. You can see this is the table that we just did, where it's going up by a factor of 3 for every additional change in 1. On the x, we multiply by a change of 3 on the y. So they want us to go backwards on this. So I'm just going to sort of add it on here. So we want to go back -1 and -2. So we want to think about, well, what's the pattern? To get from 3 to 6, I could either add 3 or I'd multiply by 2. To get from 6 to 12, I could add 6 or multiply by 2. So the multiplying by 2 is the pattern that holds. So to go backwards, I would divide by 2. So 3 divided by 2 is 1.5. And 1.5 divided by 2 is 0.75. And then they wanted us to graph it. So we can just make our graph right here. So when we're at 0, we're at 3. When we are at -1, we are at 1.5. We are at -2, we are at 0.75. Harder to do that with the stylus. When we are at 1, we are at 6. And then it just takes off from there. So knowing that this is exponential, I know my graph is going to look like this. and it is going to approach that x-axis, which is my asymptote, but it's never going to touch that x-axis. Similarly for this table, we start at 2 and we go to 10, so that would be a times 5. 10 to 50 is a times 5, so you can see the pattern holds. You always want to check it for more than one number. And you're adding 1 every time on this side. Just be sure that that's what you're doing every time. Okay, so then to go back to -1, I would need to divide by 5. So 2 divided by 5, just make it 2/5. To go back to -2, I would need to divide by 5 again, so it would actually be 2/25. Because it's the same as multiplying by a fifth. So then to graph it, I'm at 0, I'm at 2. When I'm at -1, I'm at 2/5. When I am at -2, I'm at 2/25, so I'm very close to that x-axis. The key is just don't go over the x-axis. And then when I am at 1, I am at 10. So I can kind of just use the grid next to it. An arrow, if you can believe it. And there we go.